Alright, this is the video for lesson 0.2. We're going to take a look at some AICE review today. We're going to look at a paper from 2010, and we're just going to look at some of the key skills that you would have learned while doing that class. Alright, let's make a start. Alright, question 1. Express this in this form here. We should recognize this as a completed square form here. So to complete the square, we do half the coefficient of x. So half of -12 is -6. Now you can check by using FOIL on this one. You'll find you'll definitely get x squared. You'll definitely get -12x. You're also going to get -6 squared, which is 36. Now I don't want 36 for this question. I want just 1. So if I do 36 take away 35, then I do get 1. So that's my completed square part at the end. Just a reminder what this actually means is the x squared tells you this is a quadratic, that nice U shape. But it also tells you where the vertex is as well. So the vertex is the opposite for this one, +6, and then -35. And you could easily check that on a graphing calculator if necessary. And you could also use that question for finding a range as well. If the lowest point on the graph is -35, then y would be greater than or equal to 35. Okay, next question. Sketch the graph of 2f of x if this is the graph of f of x. So this is transformations, which I think is chapter 11 in AICE 1. And the 2 at the start means it changes the height of the function. So every value of the function, you're going to multiply by 2. Now if the function's 0, which it is here, 0 times 2 is obviously 2. If you look at this point here, which has a height 2, then 2 times 2 is 4, so it would move the graph up here. If it has a height of 1, 2 times 1 is 2, so it would move up to here, and so on. So it has an effect basically on the slope of the graph. And you can see that is here. 0 times 2, still 0. 2 times 2, 4, 1 times 2, 2, and so on. So you can see it's the same shape, but it just changes the steepness of the graph. Describe the transformation, which transforms the graph of f of x to f of x minus 1. So the ones in parentheses, this is the one that's the horizontal translation, and this one's going to move it one place to the right. So as it's 2 points, you should make sure you've got 2 things in there. So horizontal translation is certainly important to show it's like a slide, and also right one place would be important as well. It doesn't ask you to draw the graph, but that's what it would actually look like if it did ask you to do so. Okay, question 3, 7 points, all the points here. Find the equation of the normal to the curve given here at this point, giving your answer in this form here. Now, we did a question with equation of tangents in lesson 1, so it's going to be similar, and we know for normal we're going to do negative reciprocal for slope. So you should certainly start by following that method. Notice for this one, they have actually given you the y coordinate, so the only thing we're missing here is the slope. We have a coordinate, we just don't have a slope. So to find the slope, we're going to differentiate, bring the exponent to the front, decrease the power by 1. Differential of 7, of course, is just 0. Differential of number is just 0. And then once we have our expression for slope, we're going to substitute in our x value up here. And if we do that, we should get -4, I'm hoping. And that means then the slope of the normal would be the negative reciprocal, which would be 1/4. So if we have our point and we have a slope, we can use the point slope formula. I substituted in directly this time rather than writing the formula out, which is a bad habit really. Now, normally most people would distribute here. Notice in the question though, it says a, b, and c have got to be integers, so we don't want any fractions here. So it's easier to actually multiply both sides by 4 here to get rid of the fraction. And then you can go ahead and rearrange until it's in that form that it says here, which is also called general form, I believe, in Algebra 2. Question 4. Exponents. This goes back to chapter 2, or indices if you prefer. First one's only 1 point, so it must be something simple. 3 to which power is 81? If you're not sure, just keep multiplying 3's together, and you should find that it's 3 to the power of 4. So the answer is 4. Now for this one, a couple of different ways you could do this. You could try squaring both sides to get rid of the exponent here. I think it's easier for this one just to do your power to a power rule. So I'm going to do everything to the power of a half, which just means do a square root. So 36 square root is 6. And p to the 4 multiply the exponents when you do power to a power, so 4 times 1/2 is 2, and then that equals 24, and then we can solve this easily enough. Divide both sides by 6, and then do a square root, not forgetting plus or minus for this. I just wrote it as 2 or -2 because I couldn't find the plus or minus symbol easily. Okay, last one. These have a base of 5, this does not, but I noticed that 25 is 5 squared, so that's clearly important for this question. And that's the first thing I'm going to do. I'm going to rewrite this as 5 squared. Now with exponents, remember when you're multiplying, you add the exponents together. So n plus n plus 4 is 2n plus 4. Once you have the bases the same, you can go ahead and just set the exponents equal to each other, and then you can solve. This question in particular is going to be very important once we get to Unit 3, which is going to come along fairly quickly. That'll probably be about week 4 of school. We're going to revisit this idea and also look at slightly more complicated questions. So this was a good one to include this week. Another 7-point question, so a pretty high question here. Solve the equation, given your answer in this form. Now, you'll notice someone's got a radical in it, so this is not particularly a nice question. Normally when we've got questions like this equal to 0, we're trying to factor them. Well, you can try and factor this one. You wouldn't put x and x, you'd put square root of x and square root of x, because square root of x times square root of x is x, and then you'd have that middle term here. But try to find two numbers at times to make 13 and add together to make -8. That's not going to be an easier task to do. So the better option for this one is, go back to what you learned on that earlier question. You can complete the square on this one. You can't use quadratic formula easily on this. Certainly doesn't factor, so completing the square is your third option for this. So half the coefficient of -8 is -4. Notice I put the radical x here, once again, because radical x times radical x is going to be x. Radical x times -4 and -4 radical x will give me that -8 radical x. -4 times -4 is 16, which I don't want, I only want 13, so I would need to subtract 3. Once I got it equal to 0, I can start solving, add 3 to both sides. I can do a square root of both sides. Technically, it should be plus or minus the square root of 3 here. Square root of x, and I can add 4 to both sides. And then to get rid of this square root here, I just square both sides. And not the neatest for this one. This was before I actually had some of my technical tools, so I apologize for the neatness of the writing when I first came up with this solution. Question 6. One of the more complicated ones, particularly when we have coordinates in terms of variables. We know these are always going to be slightly more difficult to work with. Make that slightly bigger. There we go. If I just move question 6 off the top there, I can make this slightly bigger still. There we go. So find by differentiation the value of the gradient at the point A. So this point here. So we have the x-coordinate. We just don't know what the slope is. So to find the slope, we differentiate. So the differential of x squared plus 5 is going to be 2x. And as x equals 1, we can just substitute in and we can find the slope is 2 at that point. Fairly easy question just to get us started. The line segment joining the point A and B has a gradient of 2.3. Find the value of A. So a line segment, to find the slope of a line, you just go back to algebra 1 and use your formula. y2 minus y1 over x2 minus x1. So I got a squared plus 5. Subtract y1, which is 6. All divided by x2 minus x1, so a minus 1. Now, I did a couple of steps at once here. First of all, I set it equal to 0. This is my equation of the slope, and it says that the slope is, or the gradient is, 2.3. So 5 take away 6 is -1. So a squared minus 1, I notice factors, because it's difference of squares. So a plus 1, a minus 1. The bottom also has a minus 1. So what I notice here is these two terms actually cancel, and I just get left with a plus 1. Find the value of a, so remember this equals 2.3, so equals 2.3, and then if I subtract 1 from both sides, then I can find out that a is supposed to be 1.3. State a possible value for the gradient of the line joining the point A and C. So as I know that the slope from A to B, because I just worked it out, was 1.3. Oh, actually, I apologize. If I plug 1.3 into this formula here for slope, then I would actually get 2 times 1.3, which is 2.6. And I know that the slope at this point, A, was just 2. Therefore, I can say that the values must be somewhere between 2 and 2.6. You can see the slope here is increasing. So if the slope here is 2.6, and I can see that this slope is 2, then it's got to be somewhere between those two numbers. Try and identify each graph a little bit small. Let me see if I can make that one just a little bit bigger. I think it's because I've got to get the writing on, which makes this slightly more complicated. You can clearly see they're different shapes here. Some are positive some positive x squared, and some of them are negative x squared, so that might be enough for us to figure it out. 3 minus x all squared. So the ones in parentheses, I know this is the one that's going to slide the graph across. It's going to be what makes the thing in parentheses 0. So 3 minus 3 would make 0. So I know this has an intercept at 3. Now also, if I was to multiply this out, I also know negative x times negative x is positive x squared. So I know it's neither of these two graphs, and I know it must go through 3 on the x-axis. So I can confidently say that A is going to be figure 3. Now, although I revealed the answers quickly, this one should be trivial. X squared plus 9, positive x squared. This is the only x squared graph left, so it has to be this one. But also, you can see it moves up 9 places as well. And for the last one, when I do negative x times x, I get negative x squared, so I know it's between these two anyway. But I'm also looking for what makes zeros. So 3 again would make that 0, and negative 3 would make that one 0. So I can see figure 4 has 2 intercepts for this one. Give the equation of the curve, which does not correspond to any of these ones. So I've got to look what's significant about this graph. Well, a couple of things. I know that it's upside down, so I'm going to need a negative in there. And also I can see it's moved 3 places across. So to show it's moved 3 places across, remember to do the opposite here. So I've got negative 3 here. I've also got the negative at the start of the question, and then I'm going to square it. And you could check on a graphing calculator at home if necessary, just to confirm those results. Now, question 8, this is from a paper in 2010. This first question actually is now part of the AICE 2 curriculum, so I'm just going to skip straight to that question and give you the answer, and you don't have to worry about it too much. Really, it's a complete and a square question. X squared plus 6x, you can see I've got my half the coefficient here, and y squared minus 4, and I got my half the coefficient again. We'll look at that one in chapter, I think it's chapter 11 for AICE 2. Find the coordinates of the point where the circle meets with this line here. Now, this one is an AICE 1 question, because I'm looking at when does this equation intersect with this equation. And this one's one you'd want to do by substitution. As you have x's and y's here, and you know what y equals, you can literally just plug in for y. So there's the equation of the circle. Wherever it says y, I'm going to plug in this 3x plus 4, and that's as far as I'm going. You should be able to do FOIL on this. You should be able to distribute this. As it's x squared, you'd want it set equal to 0 if it's not already, and then you'd want to go ahead and solve that by either factoring or the quadratic formula. Number 9, this is one we practiced the other day. F dash of x just means that first differential, and F double dash of x means differentiate twice, and then plug in the value of 4. So I'm going to leave that one for you, but just remember that first step. You want to rewrite expressions. So 1 over x, you want to write as x to the negative 1. Square root of x is x to the power of 1/2, and then you should be able to continue that. So this is not differentiated right now. This is just rewritten to enable us to differentiate. Tough question here, one we often forget, and I think this comes back to chapter 4. Here's an equation, show that it has equal roots. So the key part for this question is this fact here. We're actually looking at the discriminant of this question. So we have 2 real roots, 1 real root, and 0 real roots. Now the 1 real root is, we actually have 2 roots, but it's the same root. So when it says something has equal roots or identical roots, then we're looking at this case here. We want to know when does the discriminant equal 0. So A is the number of x squareds, B is the number of x's, and C is this last term. So B squared is negative 30 squared, which is 900, minus 4 times A, which is the number of x squared, so K, times by C, this term on the end, 25k, and it equals 0, so set it equal to 0. You can see I already simplified this first term, and then we just go ahead and solve. Add 100k squared to each side, divide both sides by 100, so k squared equals 9, and then once again don't forget plus or minus to find out the two values, 3 or negative 3. That first step's really important. Now, if you miss that, you might pick up 0 out of 4 because you can't actually start answering some of the easier parts to this question. So a good one to look back on. This is our last question. This one's kind of a longer question here. 2, 2, and 7. We got a lot of points on here. The lawn is made of the shape below, and the units are meters. All right, I'm going to zoom up a little bit now and make this bigger. Now we know what that actually says, and we can see it a little bit better. The perimeter of the lawn is P, find P. Only 2 points, so it can't be anything too complicated. So perimeter, you just add all these sides together. Oh, it didn't tell us this side. Now, this one's probably not as obvious. I'm surprised this wasn't 3 points, at least. So what I'm going to have to do is I'm going to have to drop down a perpendicular here because I want to find out what's the length of this hypotenuse here. Now, to find this length here, if I do this length, take away this length, it would actually give me this length here. So 5x take away x is 4x, 2 take away 2, 0. So in other words, it's just 4x. As this is 3x, this is actually a nice, easy Pythagoras questions. Hopefully you can remember the 3, 4, 5 triple, and if not, you can just work out through Pythagoras. So the length of the whole shape is this, plus the 5x that we just worked out. And if you collect your like terms here, you should find that's 14x plus 4. I think that's a lot of work for 2 points, though. Show that the area of the lawn is given by this. Now, they haven't given you the formula, so it's one you've got to know. It's a half times base 1 plus base 2, or in parentheses, times by the height. So if I add these two together, I get 6x plus 4, and if I half that, I get 3x plus 2, times by the height, which is 3x. And then if you distribute that out, you'll find you get what the answer says here. But once again, reliant on a formula, so once again, we need to know those formulas. Last part, 7 points. Whew. Perimeter of the lawn must be at least 39. So in other words, this must be greater than or equal to 39. So we're actually going back to verbal and algebraic expressions, which I'm actually currently doing with my Algebra 1 students. So greater than or equal to 39, take away 4 from both sides, gives us 35, and then divide by 14. And if we simplify this, we find greater than or equal to 5 over 2. No big problem so far. It also says the area must be less than 99, so this must be less than 99. I divide both sides by 3, and I bring this term across to the other side as well, whichever order you prefer to do. Once I've got here, I've got to factor this, or I've got to use a quadratic formula, or I've got to use some method to find out what my zeros are for this question. So I factored because I figured out what the two numbers were. 33 I recognise was 11 times 3, and it works kind of nice. And then I can look at what these key values are here. I believe the inequalities unit is chapter 5 from AICE 1, so if you're having difficulty on recognising which part you're supposed to be looking at, you might want to go back to that. But basically, and this is not going to be a great graph, I know it's positive x squared, so I know it's this U shape. I know that one of the limits is 3, one of my zeros is 3, and the other one is negative 11 over 3, which is here somewhere. And then I can draw in my x squared graph. So less than 0 refers to below the graph, greater than 0 refers to above the graph. So I'm looking at these points here. So in other words, it's between those two numbers that I found. So negative 11 over 3, less than x, less than 3. Now, these are both found independently, but it says it has to work for both of these two cases. It says and. So it's not just one and the other. I've got to look when both of these apply. Now, 5 over 2 is 2.5. So it's got to be greater than 2.5 straight away. So I can't have these negative values. But I know it's got to be less than 3 as well. So there's my final solution. Make it between 5 over 2 and 3. And that actually finished it for this paper. Originally this paper was split into 2. The AICE 1 now is just done as one whole exam, but it used to be split into 2. So you'll notice there are some key topics missing. For example, I didn't see arithmetic and geometric sequences. I certainly didn't see vectors, although we'll cover that in AICE 2. I didn't see any trigonometry, and I didn't see any volumes of revolution, or actually integration either. So it's not a fully complete review, but it does contain some key skills that you should have learned in AICE 1. Those questions that we didn't finish, you should certainly go back and make sure that you look at those. Go finish off those answers, finish off that last bit of algebra. That's it for this video. Go practice. If you need additional help, I mentioned some of those units from AICE 1. Go back and look at the YouTube channel and find those as well. And that'll do it for this video.